Hey everyone, and welcome to episode 7 of the top-down shooter tutorial in Godot. In this episode, you're going to learn how to refactor your project, how to use node-based composition, and how to separate a weapon scene from your player scene. So this is actually the third time I've tried to start this video. Each time I've tried to do some reorganization of our file system, and I've gotten a crash to desktop. So I don't know if this is just a Mac thing or Godot in general, but moving and reorganizing things in your file system from the editor is definitely one of the parts about Godot that still needs some work. So what I tried to do, I'll show you in a sec, but I created a weapons and an actors directory. And I moved our player scene and script as well as our enemy scene and script into our actors directory. Then it crashed. And then I opened it back up and tried to move our bullet into our weapons directory, and it crashed again. The good news is that it worked, even though it crashed, but now that I'm here, we're getting some missing dependencies, which is because we previously had our enemy loaded in for our main scene, and I think because of the crash, it's not able to find where our enemy is now, and that's okay. So we can just go into Fix Dependencies, select this, and change our path to find our enemy again, which is just right here, and that should fix it. And yeah, should be good. So now I can hit Open anyway. It's just kind of misleading. Okay, so now we have an enemy, and it still knows how to go there. Knows how to resolve that scene. So anyway, I'll just show you what I did since I'm crashing every time I try and do it. But like I said, I just moved actors into here and just moved our bullet into here. And later in this episode, we're also going to be creating a weapon scene that our enemy and our player can use, and we'll be using it, or we'll be moving that into here as well. So we're just starting to build some nicer organization around our file system. And so if you try and do this and follow along and you get crashed to desktop, don't worry, just open it back up. You might have to, point the engine into like where you've moved things, but it should still work. Okay, so now that we have some reorganization, we can actually start doing some of the refactoring we meant to do. So we're going to start with just doing some small refactorings, and then we're going to get into the big and more exciting stuff. And as a quick note, I did change and up the scale, the display scale of my editor, so I hope it's a little bit easier to see, but let me know in the comments if there's still issues or if it's hard to see. So the first thing we're going to do is something we talked about a little bit in a previous video, which is give a class name to our player. Now, there's not a huge downside to giving class names to everything, but you don't really want to do it for every script you have because it's just going to clutter up the global namespace. You really only want to do it for scenes or scripts that you're going to be passing around and referencing a lot. And for our player, that's definitely the case. We're going to need to access a player script in a lot of places. So I'll call this class name player, hit caps lock, player. And then what I can actually do is go into our main scene. And part of the cool thing with static typing is that you can even type scenes within your, or other nodes or scenes within your scene tree. So I can actually type our player variable as a player now. And we're not currently doing anything where we're interacting a lot with the player. Connect is just built in, so we don't actually need to type it to get that. But going forward, this will be really nice. So now we've got our typed player, which we'll be able to reference going forward. One other thing I want to do is that we talked about in Bullet when we were creating these, that whenever you do anything that involves movement or physics, you want to have it within the physics process function. And so if you look at our player, we were actually previously doing stuff in process. So the first thing we're going to want to do here is just change this to be physics process. And sometimes when you do this, depending on how your code is structured, you might notice things slowing down or looking different. And that's just because your code is now not dependent on FPS where it was before. The way we had it, it's going to look pretty much the same. But the good news is that we're going to have the same movement and animation and same feel regardless of what the FPS is. So this is a good change. And we can close this. So now that we have all of our code changes done, we can actually start to look at refactoring some of our scenes. And the first thing I want to tackle is the fact that we have health variables on both our player and our enemy, but it's being used and we're interacting with it pretty much the same way. And one of the core principles of software development and architecture and or organization is called DRY, which is an acronym for Don't Repeat Yourself. And the idea is just that if you are writing the same code in multiple places, it's probably a sign that you can extract it into one common place. And it's important to note this is not always the case, especially in games when you're going to have different scenes or things that really need to have custom handling for certain things, but whenever it makes sense to extract something out that's being used in multiple places, we want to do it. And so we're going to do that first here by creating a common health scene for both our player and our enemy to use. And this is kind of a contrived example. This is not like, it's not really complex, so this isn't a great place to do it right now, but as we scale our game, we're going to see how this will make a lot more sense. And so in order to do this, I'm going to come into our player scene. And the way I'm going to do this, there are many, many ways to make functionality like this common. One of my favorite ways is called node-based composition. And what it means is that you create a node, a separate node in your scene tree that basically stores the information you need, and then you just access that. And it's going to look pretty much the same as what we have now, where we're just accessing a health variable in our script. But the nice thing is it's going to be a separate scene that we can save off, and then we can just drag and drop in any other scene in our game that's going to need it. So let's get started with that, and you'll see an example of how it works. So when I come into our player scene, I'm going to just create a new node TD because we don't want this to have any visual representation. We just want it to contain data. I'm just going to call this health for now, and I'm going to attach a health script, which I think I already did as I was testing things. So you'll see we have one in our actors directory. So we'll create that. And all I did is I got rid of all the other stuff, and all it has is an export variable called health, which is just an integer. And so now we've got this here in our scene. And what I can actually do with our player is come in to our script. I can get rid of the current health variable we have. Come down here and add a new onReady variable health, which is just going to be health. I'm going to separate this. Eventually, if we were to have more stats, what you could do is have a node 2D like a stat container, which would have individual stat nodes underneath it, or maybe you would just have a general stat node that had more than just health. There are so many ways to do it. It's very game and situation dependent. For now, we're just giving a very simple example of how this works. So we've got health here, and if we come down here, you see that this script is still, the editor still thinks it's valid because we're saying health minus equals 20, but this is a node now, so we can't just say health. And so if you look at our health script, we have a variable called health on it. So we could do health.health here, which would work, but it's kind of, it kind of looks dumb, health.health, and we want to make sure that we have good ways to access this. So what I'm actually going to use is Godot's built-in setGet functionality, which I'll just type here and explain in a sec. Set health. Okay, there we go. So with a setGet, you basically can define a setter and a getter. I generally tend not to use this, but there are some situations where it is super, super helpful. And this is one of those situations. So I'm going to define a function here called setHealth. Whoops. And this will just take our new health. Will just be an integer. And then we will say health equals new health. Now, so what a setGet does is it means that whenever any other node, like not internally within this script, but another node or scene in the tree tries to access this health variable and set it, this function is actually going to get called. So we can put some handling in here to make sure that we're always getting a valid value. You can also do the same for, we could do like get health and define that if we had some special way we wanted to present our health. In this case, we don't, and I can't really remember the last time I've wrote a getter. It's really just a setter for me. And so here we're basically, like, this is doing nothing right now. It's just setting our health to what gets passed in, which is the same as just accessing this. But what we want to do is actually make sure that we're keeping our health within a valid range. So in order to do that, we can use Godot's built-in clamp function. And so what this does is you pass in a value, and then you give it the min and max values for it to stay between, and clamp will make sure that it stays between that range. So we're saying, give us whatever the player or whatever the user tried to set our new health to, and then make sure it's between 0 and 100. So if it's less than 0, it'll get bumped up to 0. If it's over 100, it'll get bumped down to 0. And this makes sure that our health is always within a valid range. And so this is just a really simple functionality wrapper around trying to set our health. And eventually, other cool things you could do is, like, we could say emit signal, health changed, which is probably what we're going to get to pretty soon. But right now, we don't really need that. So we'll skip it. But just an example of what a setGet is and how it can be helpful. Okay, so now that we have set that, we can actually come back to our player And you'll see now whenever we do health.health, it's actually going to be calling that set health function we defined under the hood. And I'm going to just rename this to be health stat. Yeah, we'll just do this for now, just so it doesn't look kind of silly saying health.health. Again, this is kind of a pretty simple, contrived example. Normally, it'd be totally fine to either just do this as part of our player and enemy scripts, or to have a resource or something that we used, but we'll just do this for now. And then call that good. And oh, whoops, here I need to do health stat.health as well. So we'll just keep printing out our player hit. And once we start handling player death and do UI stuff, we'll do some more interesting things here with signals. Now we can come into our enemy and do, oh, actually, before we do that, the whole point of this is we want a scene, like a health scene that is reusable. And so what I'm going to do is actually save this branch as a scene, and we'll just call it health. We'll save this within actors as well. And now what I can do is come into our enemy scene, and I can hit this button, which lets you instance a child scene, and I can instance our health, and we've got that same functionality already. And so all I need to do from our enemy, replace this unready var health stats, which will equal health, and then same thing here. So we can say health stat.health and health stat there. And so let's say we wanted to give the player or an enemy more or less health. All you have to do is come in here. We can set our enemy health to be 200, for example, while our player will still be at 100. So what we've done is we've given a really easy way to give any scene that currently exists or that we ever make in the future a health value that is unique to itself, that we can easily adjust and test out right from the editor, and it's super easy to integrate with. And eventually we're probably going to have some of the death and like signal stuff be within our health stat itself to make it more useful. But again, like I said, this is a pretty simple example, but it does illustrate, a nice way to give really good editor support for adjusting values and creating a scene to kind of hold common data that you want to have in multiple places without actually having to use inheritance. And like I said, inheritance is not bad at all, but generally, if you can use composition, it is cleaner, more maintainable, and more reusable over time than using inheritance is. And so this is just one possible way that you can do that. Okay, first things first, before I forget, let's go back to our enemy and change our health to be 100 so that it's not ridiculously stronger than our player. And so now the last thing I want to do, also as an example of node-based composition, is create a common weapon scene that basically any actor that needs a weapon can just add to its scene tree to get all the functionality we need. And so in order to do that, I'm going to come into our player, and similar to our health, I'm going to add another node 2D, and I'm just going to call this weapon. And so this is another example of the separation of concerns principle, which is like our player and our player controller, like the script, don't really need to know anything about a weapon or firing it. Like we should try and get that functionality contained to the weapon itself. And our player should just be responsible for movement and whatever other things are important to it. So the first thing I'm going to do is move all of our nodes in this tree that are specific to our weapon into our weapon node that we've added. So this is going to take a little bit of refactoring. We're going to have to adjust scene stuff and script things, and before we can actually get it working. All right. So first, let's grab a couple things: our end of gun and our gun direction specific to our weapon, as well as our attack cooldown and our muzzle flash. And because of that, also our animation player right now, all it's doing is muzzle flash. So this is really an animation player just for our weapon. And we can have one for our player later, but because we don't have anything specific to the player right now, we will not include that. So now that we've got this, let's add a weapon script. And I'm going to move this to actually be, if I go up a path to our weapons, and I'm going to call it weapon.gd. And we'll do that. So let's create our weapon script here. Okay, so now what we're going to need to do is move pretty much the majority of the functionality that we have or that our weapon needs out of our player script and add it to our weapon script. So first thing we need to do is move our bullet scene reference to our weapon. So let's do that. I'm just going to get rid of these. Okay, and now we can come back here. So basically all of these references are all weapon specific. So let's grab those. Whoops, there we go. Okay, come back to our weapon, and we're gonna get a lot of unhappy stuff in our player script that we're going to have to fix. So this is going to take just a second to get all of this working. So let's grab all this out of our shoot function. Let's just set this to be pass right now and bring this into our weapon. We will make a similar function we'll just call shoot for now. And we'll kind of see what we need to put in here as it goes. So let's tab those back. Oh, whoops, most of those. So basically it's the same thing, right? Like if our attack cooldown is stopped, like if we're ready to attack, we will spawn our bullet instance. We should also check too, and bullets is not equal null. So if our attack cooldown is stopped and our bullet isn't equal to null, and that way if we forget to set our bullet, we won't get an error, which we'll have to do in a sec. So hopefully I don't forget that. So basically the same thing as before. We're going to spawn a bullet instance at our gun direction, and we're going to have to change this this signal that we emit in just a second, but then we're going to play our muzzle flash animation, which will still be here. So that should all be good. Okay, so now we need to tell our player when our gun has shot something, since our player doesn't know anymore. So I'm going to add another signal here. We'll just say signal, let's call it weapon fired. And I think we'll need to pass in our bullet. We'll have to see. So I'm going to change this to be, well, let me just copy this line. I'm going to change this to be weapon fired. Actually, yeah, I think we're going to need all of these. So let's just do location and direction. And so whenever we fire our gun, we are going to emit a signal weapon fired, which we'll need to listen to in our player. So we can do that in our ready. So I'll do onReady var weapon, which will equal weapon here. So we'll get a reference to our weapon, and then upon ready we will say weapon.connect, and we will do weapon fired, and we say self, and we will say shoot. So basically we're saying whenever our weapon fires, call the method shoot in this script. So we'll come down here, and shoot is now going to take bullet instance, which will be a bullet, a location, which will be a vector 2, and a direction, which will also be a vector 2. And it's really just going to be a pass through right now. We're just going to say emit signal, and this will be player fired bullet. So we still have that signal that we defined here on our player, and we're going to pass in the same stuff that we get: bullet instance, location, and direction. And now whenever the player clicks, we don't actually want to call our shoot function. What we want to do is say weapon dot shoot. There we go. Okay, so let's talk about this. Some of you might be looking at this and thinking, wow, this is a lot of overkill. You've added another scene tree, and now we're doing the same thing as before, but there's like 2 extra functions we're calling that are really doing the same thing. Like, what is the point of all that? And that is a very valid question to ask. So in Godot, one of the best practices that you'll hear a lot is call down and signal up. So when you have a node that wants to do something with a child node, that parent node can rely on the fact that that child node is there because it's part of the scene tree. So our player can rely that it has a weapon. And so we can call weapon.shoot from our player. But our weapon should be designed in a way so that it doesn't depend on it having a player as a parent or any parent. And so we use signals to provide an API or a way for other nodes to listen to things that happen as a result of it without them having to be there. So our weapon will fire this weapon fired signal whenever it shoots. It doesn't matter if anything actually listens to it, it'll just fire it. And so now our weapon can exist on its own. It doesn't need anything there, and it's not dependent on having a certain type of parent, which gives you a lot of flexibility going down the road. And so it is definitely true that it's a little bit more overhead in doing it this way, and we've got an extra signal that we have to call that then gets handled from our player. But right now it seems like some overhead we don't need, perhaps, because we're not doing anything else. But once your game expands, very often you'll have stuff like this where not only would we be firing this signal, we'd also be doing a lot of other things and handling. We might change something on the player or whatever. So this makes it way more easy to maintain and build on going down the road. And another really nice thing is that our player doesn't care whether our weapon shoots successfully or not. It just calls weapon shoot. And whether it happens or not, the player doesn't have to know anymore. It's just delegating all of the responsibility to do that to our weapon. And our weapon will communicate to the player whether it was successful in shooting. And by successful, I mean, like, did it actually shoot? Like, is our cooldown up? Do we actually have a bullet? So our player doesn't actually care if it does. And our weapon will communicate back to our player whether it was by firing the signal. So it's really nice because it's asynchronous. Like, our player can just tell the weapon to shoot, and if it doesn't work, like there's a cooldown or something else, then it's totally fine. Our player doesn't care and it moves on. But if we do actually shoot something, then our player sees or gets the signal back and say, oh, okay, we did actually shoot. Now I can tell our main scene that we've got a new bullet that needs to be spawned. And eventually we can eliminate some of this overhead by getting rid of this method. We can maybe make our weapon fired or like bullet spawn signal be global, so we can just communicate directly to our bullet manager. Plenty of ways to make this nicer, but sorry for kind of a longer explanation there, but I hope it's helpful why doing some of this stuff is really valuable. Even if we don't necessarily need it right now, it helps your game be easier to build on. Okay, so before we forget, while I'm still thinking about it, let us add our bullet to our weapon here. And then what I'm actually going to do is make our weapon its own scene. So we will save a weapon scene within our weapons directory. And if I go to this now, you'll see that it has no sprite. And this is because our weapon is currently attached to our player. And so something I want to do is make our player sprite independent of a weapon and make the weapon actually its own sprite. And so in order to do that, I'm going to add a sprite here to our weapon. I'll just move this up to the top. And I'll come up to our the Kenny, the top-down shooter, and go into the PNG, and then you'll find the weapon silencer, which is the current pistol we're using. So I'll select the sprite, drag open the weapon silencer, and then I'll set that to 0. And what I'm gonna do is just reset all the positions for all of these. Actually, I'll set that at 0, 0, and then drag all these. Let's set the position to be right there. Let's set our end of gun to be, set our end of gun to be right here, and our gun direction to be right there. Okay, so that should still work. We might need to adjust, our muzzle flash animation got kind of busted. So sometimes when you reorganize scenes, your animations can get messed up, but here's a nice trick, is this can't resolve these properties right now because it's trying to find weapon / muzzle flash, but there's no like other node named weapon here. Even though it's the name of the root, it's looking for another one here. So if we just click on these, we can actually change the name and get rid of this weapon here. So it's just looking at muzzle flash, and we'll see that it picks that up, and we can get rid of that. And there we go. Now we have our animation that is good to go, and it should just be the same as it was before. Ah, cool. There we go. Okay, so now that we have the animations all good, we need to actually make this work on our player. So I'm going to come up here, and I'm going to move our weapon now so that it overlaps with our player. Should just be, it's pretty close. And what we're going to need to do now is change our player sprite so it doesn't actually include a weapon. So if I come over here, we'll come into our region, and I'm going to zoom in. And there should be, right, oh, here we go. Ooh, that's sensitive. I'm just going to set it to be the player with 2 outstretched arms, but not holding anything. I need to drag this up as small. There we go. All right, let's try and get that. Let's do that. I think I have everything on the top. Not super important, but close enough. Okay, so now our player sprite is just the player. I'm going to drag this back into the middle, and now we can drag our weapon down here. And so it looks like our player is still holding a weapon, but now potentially we could have it where a player doesn't have a weapon equipped, or we could swap this to be another sprite, or we could have different weapons, and then it would be totally independent of our player. And so what we've done is we've actually made our game a lot nicer and more flexible because it lets us swap sprites in and out easier. And so the last thing I'm going to do, just the same thing on the enemy here. So I'm going to get rid of our end of gun, muzzle flash, animation player, etc. Delete that. And I'm going to instance our weapon. Move this up here. Let's adjust our sprite here as well. Come down to our, here we go. This one here. I need to move this step down just a little bit in the X direction. Okay, should be perfect. Now I can drag our weapon down here. And, oh geez, let me turn the snap off. So many things, always. Drop our snap down to 4. Now I can move this. That's a little bit better. We'll just do that for now. And cool. I think the only other thing I'm gonna have to do, no, not even, because we're not even doing any shooting with our enemy right now. So now if I run this, we'll see that we've got a player and a weapon still and our enemy, but that everything's still working. We can still shoot and we can still kill our enemy.